All right, first thing I'm going to do is I'm going to rearrange my terms. All right, I want to rearrange the terms so that I can set this up for completing the square. So in other words, if I'm going to complete a square, perfect square trinomials, I need my x squared and my x term together. I need my y squared and my y term together. All right, and then this 20 is an extra little number. I need to get rid of it, so I need to put it on the other side of the equation. So when I rearrange my terms, I'm going to have the x squared first. I'm going to then put the plus 10x next because I want to set this thing up. Then I'm going to do a y squared and a minus 4y. I don't want the 20 on the left-hand side, so I add 20 to both sides of that equation, get it moved over there, so then I've got a equals 20. All right, now generally, I go ahead and I start to group these two together because I need to start thinking of these as, hey, I'm going to create perfect square trinomials. All right, so now I'm going to complete the square. So I'm going to make my perfect square trinomials. All right, so what I'm going to do, this I'm going to turn into a trinomial. This I'm going to turn into a trinomial. So I'm going to go x squared plus 10x, and then I need to put something right there in order to make it a perfect square trinomial. So I also need to do it on the y. So y squared minus 4y, and then I need to put whatever goes right here that's going to create that perfect square trinomial. Okay, now what do we know about equations? If I add or subtract something on this side of the equation, don't I have to do the same thing over here to keep it balanced? Okay, so I put something here, I got to have a spot there. And if I put something here, I got to have another spot here. This is what people forget. They do this just fine. They create this perfect square trinomial, but then they don't take the two things that they inserted into the equation here and they don't do it on the other side. So then their equation isn't balanced anymore. Okay. All right. Now, do we remember how to get this number? How do I create a perfect square trinomial? Ooh, I don't have a formula for b over 2 squared. Oh, b over 2. Yes, it is. All right, I take this, I take half of it, and then I square it. So yeah, all right, I never memorized it as a formula, but it is. I just memorized take half of the b term, which is 5, square it, it's 25. So yeah, plus 25. Very good. All right, if I add 25 on the left-hand side, I got to add 25 on the right-hand side. All right, we're going to do the same thing here. If I take half of 4, that's 2, and square 2, that's going to be 4. So I'm going to add 4, and I'm going to add 4. Okay, now, depends on how you were taught this, but this at this point right here is a perfect square trinomial. All right, we did this on purpose because we want it to factor nicely. All right, so this first thing right here, that's a perfect square trinomial. All right, this is also a perfect square trinomial. I'm not going to write it out again. All right, and we did that so that it will factor nicely, because what? When this factors, I should have an x plus something and an x plus something. I should have two of the exact same things. All right, well, it's going to be x plus 5 times x plus 5. It's half of that middle term. All right, so it factors really nicely into an x plus 5 quantity squared. This trinomial factors to this. Again, why factoring is so important. All right, if you know how to factor a y squared plus a 4y plus 4, it's a perfect square trinomial. It's going to be a y minus 2 times a y minus 2, which means a y minus 2 squared. All right, and then I add all this up over here, 20 plus 25 plus another 4. Was it like 49? And now that's standard form. All right, because that perfect square trinomial factored nicely. This perfect square trinomial factored nicely. And then I got the right radius.